All right, thanks guys for your time. Before we get into it, I'll do some quick intros. I think it's great to have the whole project team so you can see them face to face. So I've got Jason Camillo next to me. We've engaged him to the end of the year really to help us really break down the work that we need to do and help us get to the end and taking on a lot of those BA type activities. We've got Branko, as you've heard a lot lately. He's coming to take the lead on all our QA stuff. I know you've got already a lot of questions for the flyers and fancy parts and scan lines and all that sort of stuff. So you hit the ground running. Rowan, I think you know already. Data scientist role, you know. The great Dave, you know already.
G'day, Dave.
We've got Craig, our AWS architect, Guru. And for everyone else, we've got Hugh, who's our head of education management, and we've got Jason, who's representing IT. And
You're probably on your own today. You normally get running packs. Unusual, but please get me. You're not charging for this.
Thanks, guys. Brilliant. That's how we roll.
Yep.
And Peter, of course. Just swing over after this. So the purpose of today is really to, I send out packs to you guys and increment percentage and all that sort of stuff, but I guess there's no better way to show you our progress in real life. Some real goals have been met, I guess, in this last sprint. So what we set out to achieve is really to start to build that front end pipeline, this big pipeline that we're, the LiDAR pipeline that we're trying to build, the end-to-end pipeline. So there's a lot of foundational work that we'll be demonstrating today. As well as that, one of the key activities that we did in this week, we engaged a LiDAR expert, Adam Steer, and he came in and we had a full day workshop with him. We ran through our approach and what he thinks, and the great thing that came out of it was they really endorsed kind of what we're doing and the tools that we're using and the approach that we're taking. So his actual words were, to me when I was dropping him off, it was like he thought he was going to come in and tell us what to do, basically, and it was the other way around. He said, you guys are on the right track. So it was a good vote of confidence for us, really was.
We're getting back.
Yeah, so we've engaged him on an ad hoc basis. So we brought him in for a day and a half, and the guy flies all over the world. He was off to the airport yesterday, Tuesday. He's off to Indonesia, sorry, and so we'll be doing it remotely where we can. He'll be sending us a kind of a 2-pager summary of the day we had. So, but yeah, he's a resource that we can tap into as we need. Yep. Yeah, cool. And this viewer that we're going to show you, this new tool, very cool. It really, from a data quality perspective, it's a real quick way to zoom in on the network and look at the last files and see what sort of data quality issues we've got. At the moment, we kind of load a file at a time and view it. This viewer that you're going to see today is the whole network, or HRL, whatever network that we've loaded. You can actually scroll through the span of 5 pages and see that really cool stuff. Yeah. The last thing I want to kind of try and hand over to Peter is to give you kind of where we're at. Is, you know, what we're showing today is we've built some foundational work. This is the data ingestion part. So this is kind of taking the LiDAR, classified LiDAR, and putting it through this initial ingestion part to be able to do the modeling and all that sort of stuff. So, and then the next sprint, the next 2 weeks, we plan to build on it and do it at some sort of scale. So 500,000, what it might be. And then as we go through the sprints, we'll keep scaling that. So I know Peter's got some numbers as to the processing capability at the moment, which he will share. But on that note, I don't know if you want to add anything else, Pete. On that note, I'll hand it over to you.
Yeah, we'll talk through it. So, yeah, this is a little bit rough because we're basically building from the ground up. So we're down to show you the process. So here's the sort of high-level view of what we're looking to put together. And we'll just focus in on the front part of this. But just to give you a quick overview of like what we sort of do our scope as. We're getting classified LiDAR from someone. We're building this LiDAR platform, which will focusing in on today is like what we've been building, and we're really looking at these sort of first three steps. So we receive, at the moment, we're using the AAM data, so we get that file. We need to standardize those, so we'll convert those into layers files, which is a compressed version, but reproject them into a common coordinate system. We'll create this EPT data set, and this is kind of the data set for both running our models as well as visualizing what we're doing. Because it will enable us to load and manage the whole network LiDAR in one spot, in one sort of bucket. Like, it's not a database, but it's a file structure which works really well in this use case. And then run the models on DPT data. So you'll be AWS experts by the end of this. So I'll just flip over to. I'm sorry. I'm joking.
Please.
There's that nice thing going on in the humour. There's that. It's a unicorn. Yeah. Grab him, cage him.
Yeah. Okay, so this is, I'm going to walk you through, this will all happen kind of in the background, but we'll walk through and pretend we're machines today. So this is AWS, we've got a bucket here, which is where we have development environment called LiDAR delivery, and we're kind of simulating receiving data files. So in this input folder today from demo, we'll get a lapse file. So this is the input. So this is currently what gets made. What we'll do is show you it running, and basically the first step, which is like that standardization and projection, will the output will end up in this other folder, which looks the same except it's called reproj at the top. And if it all works, and we're in a demo now, so the chances are the same, but we should end up with this file, and this time set should update. We'll run once it again.
What sort of volumes are we talking, and what sort of time frame are we talking? What sort of chunks are we?
What sort of chunks? Well, it kind of is going to depend on how quickly we get, how quickly the data comes in. But our estimates are, if we have to process the whole network in a year, we have to be processing sort of 20,000 spans a week. That's about the volumes that.
Well, it's probably 9 months though, isn't it?
It's more so. 9 months. Yeah. We could probably do that without breaking a sweat right now. Okay. So I don't think we've got any concerns about the volume. So, for instance, in our demo environment, I ran 100 LAS files. And it'll take like 10 minutes to do this. That's on a single machine.
And what's a LAS? Give me an idea what a LAS file.
A LAS file is a span. It's one span.
Right.
Yeah. But we could run 10,000 of those at the same time.
And the last file is like 3D.
Yeah.
Yeah. The classified LiDAR.
Yeah. So that's the first step. If we get the classified LiDAR, the lapse file. I'm not sure what that then takes to be able to get it through. Would you have to just scale your infrastructure and get an extra through? If we needed it, we've got it set up so that it will automatically scale up if we need more. Is there anything that's on that scale? Application. The limit to how many machines are AWS.
So LAS, we're talking about one span from LAS to LAS takes about 10 minutes, but we can do thousands of them.
No, one span takes 100 takes 10 minutes. 100 takes 1. Yeah. So I'll just. This is like this is getting right down into the. So this is like the command line, which our orchestration tool will actually automate. But we'll just run it here to show you that it's working. And so this is taking taking the input file and running the code in here and generating the output file. And there's something like working software. So if I run that, that'll run schedule that to run on our cluster. If there's like 100 of these things, it'll schedule 100 if we want it to. And if we go back to S3, this takes a few seconds. It's reading from AWS, doing something and then writing it back. And so the timestamps update, which means that we've generated a new file. So basically, that's the first step. The second step is then to turn that into this EPT format, which stands for entwined point tile. So you'll be able to impress your friends at the barbecue and then that. No. Yeah, go away. So the next step is this one. And this one's called generate EPT. Again, the first step actually generated a config file, which tells this step what to do. So I can tell you the config file if you want, but since not many people probably ask you what that looks like, it's probably not necessary. But this will, in terms of the EPT format, the one we're going to show you later is the full HRAF. And that took me like running on a machine, took me about 3 or 4 days to process the entire HRAF.
380,000.
313.
How many spans?
380,000.
So that's all service. All service then.
Yeah. That's all. That's HV, LV, LVS, whatever we've got in direction 13. Yeah. So
this happens after the LAS turns into a LAS.
That's this step. Yeah. So
step. Right.
If we were to run this on all of HRAF,
You did a whole network in 4 days.
4 days.
Oh, okay, that sounds good.
Locally on the machine or that?
No, this is on AWS. I mean, one machine, no. We didn't even try to scale. It was a pretty big machine.
It can re-run all that 90 LiDAR program so it can pick up
Yes. Yeah. In 2018.
In 18 as well, if you want.
Yeah, do the whole lot. Okay, so this is running, and I'll just so I'll just go. This is the delivery. So EPT, where are we? The EPT ends up in in this folder here. So in our test folder, today's date, demo, and this is the EPT data structure. So we won't go into this because we don't really care, but so I've regenerated it so that the date that's one thing that I've but actually really happened. And so we've generated that. So now this EPT data structure is not only what we can use to view the network, we'll use it to run all of our processes on because it's super fast. And I don't think we need to demo it, but we've got it running on Rails machine modeling. So now that he can grab the span out of the ET and then run full models on it to generate the whole. We've seen what they generate already. So that's the guts of the ingestion process.
So can I add that, Pete? So what the one difference is before, the concept was he was doing the modeling based on one LAS file, one span. With this viewer and this standard data standardization, the whole network's there. We have to just hone in onto that, that span that we need. So he can go into anywhere he wants and do his modeling and then do his clearance. Like you're not looking at one file now, we're looking at spans. Yeah.
Yeah. So we'll show you what the viewer looks like. Because I know Steve's there, but you guys have it as well. So this is the span. That is in the HRAF LiDAR, and it's a little bit tricky, but that's like the span there, probably a whole network here somewhere, and there's the rest of the HRAF. So we'll just zoom out to that. So that's all of the HRAF LiDAR loaded, and this is we're still sort of working out whether we'll use this viewer, but effectively we'll have a view which way to go and stand, zoom into it and then whatever you want. And we'll probably also load the outputs of our modelling into the
What attributes are those?
if we go back to the database, so as we load this in, we'll be capturing all of the attributes of the data that comes through in our metadata catalog, but we'll have all of the other attributes linked into those spans. So we'll have all the conductor material, everything. Yeah.
So would I be able to type his name to the span over?
We'll probably give you a voice input. You can type it in first. Yeah. That's the idea. You can type in a span. We can probably even type in a file number or whatever and go straight to it.
Just to be clear, the visualization piece is kind of in scope. Like we're not, we didn't set out to build a visualization tool. It's necessary for us, but we can. Yeah.
We'll get the pipeline processing.
The processing of that,
Visualization is really important for the use of it, but it's not getting the data in there first step. But we'll have something available by the time, and we'll show you as we go the incremental improvements in that.
Just makes the word
Very easy. That's easy for the sketch. Yeah. So I'll show you. We haven't done any kind of customization on this at the moment. But so we're not expecting that people will do this, but effectively in here we can. This point. This is the point for the whole location span files process. If we just run that. So effectively there'll be a button here or a search box or something.
When we talk about span IDs, is that the unique span identifier in GIS?
Yep.
That's just going to be vital.
Yep. It'll be the span ID or the pole ID if you want to find the pole. But it's whatever, it'll be our GIS data which you'll be searching on.
So it's a good question for you. With VMS, that's all just going to work on span ID. So that's our reference point for everything. We're doing anything to do with span, it's like, right, what is span ID?
And we should be able to, whether we'll make it available, I guess we'll work out, but we will be able to load all of the LiDAR in here from that we've got. So it's 20, 16, 17, 18, 19, 20. And so you can actually look at a span that changes to that override.
The guys were saying yesterday that they've noticed, like Roman was talking about huge difference between 2018 and 2019 quality in terms of quality.
and 9 inch for real.
Yeah. Yep.
Oh, yes, from flying.
Flying and whatever's been sent back to us here.
LiDAR.
It's where was the one? What was the example?
We had a call out span where there was like many points. 2018 very clear. Very clear. 2019 very clear.
No conduct. There was veg. There was veg, right?
Yeah.
And what about the ground?
Isn't the veg, the quality of the data can is poor.
Yeah.
So, I don't know which detail you want to go into, but what it seems like is as they've gone into 2019, we've decided we're going to scan faster and we're going to fly higher, which limits the number of, for a single laser response, if you get one response, you get 5 responses. The more responses you get, based on how close to the ground you are or how intense the beam is, so if you go higher and higher, it gets less intense. So they can pick up one thing, which might be the ground or might be the top of the tree. So as you can fly lower, you can penetrate through the tree and get like 4 or 5 responses. The same thing happens with the line, because the line response from the line is weak to begin with. So if you fly higher, the line basically disappears and all you get is ground. So that's, you know, one of the things that we said yesterday, and it's probably one of the crucial things that we'd have to look at as the data comes in.
We'll be doing
something with the city still delay. Is it something, if they're running a decent outfit or not, they should be monitoring it, shouldn't they?
Yeah, well, that's.
I'm sort of thinking from a business perspective. We told them we're going to do the whole network this year. They probably thought, shit, that's a lot of work. And the only way we're going to do that is if we really shit our job. What's that done?
Yeah.
Well, I think what we might be specifying is like the samples per square metre, which they technically might be within. Right. They're just shooting the laser faster, and they still fall within those bounds. But what we're more interested in is how many responses we get per hit. Yeah. So we can tell them to go slower, like actually take each, instead of having 30 samples per square metre, we go, well, do 15, but we want to have multiple hits per spot. And that'll help, I think, with penetration and help with the level of the signal coming back from the line, making it.
Yeah. The other thing, I guess, is that since we've got a process to receive the LiDAR, we can actually look at it. Yeah. Right. So, you know, an hour after we get it, say,
yeah. Because we're not going to be protected for 2020 in terms of the data capture, are we?
Well, yes, in terms of the new contracts,
yeah,
by time measures around quality,
right,
as well as change to government we work through in terms of the data quality. That's very fine. It's not there. The land subcontracts that they use, so forth, they just put fast, especially for the
okay.
So if you had a good, like 2018 model, advantage of that noise, you get trips in whatever way it goes, you have to noise advantage. So you could sort of get the best of both if you wanted to. Yeah, we can use those older years actually to inform our modelling, in fact. But things move during, like, there's two movements, like the whole state shift, like the whole country shift, basically by 10 centimetres. That's like a push up. So you've got to reset after 20 years. So they're
yeah, move both ways. We're not in the same spot, right? We just keep going one way. We're all going to end up in Canada.
Yeah, it's a bit hot. So, but they're turbulent as well. Yeah, so
where's that going?
they're going to go under. They're going to go subside.
They're heading to China.
Like the projections that we use, we actually sort of discussion we've had on Monday, like there's GD 894, which is like all the Victorian kind of standard, but there's a new one here, GD 2020, which is 20 yeah. So, but we can use it, and we're definitely using the tree growth models to look at the trees and change, and we can look at the change in conductors and poles and things during the year.
There's a small thing that we can make a couple of educated guesses or decisions. So if we receive 2020 data and we look at 2019 and say 2020's got no data, we'll obviously have to feed back to the supplier and say, hey, it's not good enough, there's no data. But if we need to get work pushed through, we can use that last year's data to know where the conductors roughly are and make an educated model and do a clearance around that. So we'll have to change the veg, but we can make an educator using those conductors. That's not probably we'd have to flag it to the veg and say, hey, we've done this, we've used modelling, we've used this year's trees, classified trees, but we've done modelling based on what we know. That's to help reduce the ground inspections, I guess, that we might need. So there's something that we need to nut out. Yeah.
I mean, the point for me is that we'll be in a position for the first time where we can monitor and manage it. Yeah. We wouldn't know. We can't fair any sort of rubbish. Yeah. It's like you're in a nursing home, as
exactly
No,
right. Exactly right.
And
Yeah.
we've never really been able to look at
With the mercy.
it holistically as well.
So the poor
Hey,
sorry, care.
Sorry to put you on the spot. Are you able to show a classification issue? You know, you got like a. Do you recall? If not, it's okay. Yeah.
I'm sure we could find one. In some of these things. So, for instance, let's have a look. Well, there's just some basic classification issues. So these things here on the edge of the house is a TDS, classified as edge. So there's a whatever that is, a car or a tractor. Part of this building is classified as edge. I loaded earlier in the week all of Elbra as well, and part of the buildings inside the townships are classified as edge. So we've seen this be an issue, particularly in the city, where you've got apartment blocks that have veg classifications off the walls, and the conductors running down the street, and they're triggering cutting for fire, and it's not plans to restrict down. So those things we can see very clearly, very quickly. The other thing is, if you just zoom out a bit, we start to see So there's a misstand here from AAM. So they haven't given us this standard. They've actually classified half of the conductors. That's going to get classified as edge of these conductors. And we've got a gap. So this, you'd expect that this should be joined up because there's nothing holding that conductor.
Trees are, yeah.
Yeah, so this is, we just, look down that line. So there's, obviously, bits in here. So this is super apparent, like this. That's great. And it's that whole span for one page.
Is our intention to not only have this viewer, but have the models continued in there as well? Yeah. So you won't see the points, you'll actually see the model, the way we model the continuum.
In the whole, like
and the
where
whole.
we think the clearance is.
When we had Adam there, he showed us some models of 4 points per metre and 10 points per metre, and you can see the conductors really standard. So what Franco was saying about how it's on the returns, not on how many you get, on how powerful they are. So they're doing it at 30 there, aren't they? Yeah,
Well,
they missed it.
But it's not quite 30. They're not actually hitting.
But we can believe how good 4 was when he showed us 4.
Well, they're well distributed.
Yeah, but you can see the conductors particularly between the house and shares here.
Yeah.
So they're obviously quite too high or too far.
All right. I think that was it.
All right. But the uses there of this finder, one is a sort of as part of that QA process.
Yep.
Is that the principal use?
That's our institute, right? Yep. But I think this data, the point cloud data is a super rich asset that the whole business should be able to. So we have to work out. But giving people access to the full 3D view of the network.
That idea about having a 3D view of the network, and all sorts of propositions over the years, we're going to partner with you and all this sort of nonsense. But yes, this is going to end up being on. Well, there's other people, but if you're going to charge across the all parts and group, can you please add, I think, other groups in the business, I'm not looking at anyone. I think it's 11% margin.
Yeah, I think we can outperform that.
Was it 11? Yeah, 11% margin, so please put that on. It's 11, isn't it, Charles? No, we can't do that. It's part of the same entity. You add 11% to that sheet, isn't it? I think 21 there.
Yeah, so I think there's a lot of potential once we get.
Right. How do we cope with classifying building for speech? And is that just for the purposes of this year at the moment? Is it?
That's the LiDAR.
Right. How do we cope with it?
Well, at the moment, we can detect through the growth model whether it's a fixed structure or not because it doesn't grow. So we can make some assumptions on that basis. And I guess once we get through this part, the next part is looking at. We do that ourselves.
Right. Okay. Are we having a similar issue? Well, I know we've had all sorts of issues with LiDAR. We've got BP signs becoming business stuff. Yep. That's obviously an issue too as well.
Yeah.
On we cutting up the trees so we can teach the developing AI.
Yeah. So we'll possibly, I won't make any sense as to when you'll do it, but enhance the sort of reclassify things if we sort of detect that they're not classified. We're trying to figure out our coverage and
The last files to stack things so regardless of who's right.
Yeah. Yeah, so we currently get labs 1.1 something from AAM, but it's that's an industry standard. So that's the thing. We convert the LAS and the LAS files. LAS is just a zipped up version of the LAS file into this EPT, and it's totally lossless. So we can effectively throw the LAS files away once we've put them in formats. We find it's totally good, and we don't lose any data. And we can trace the lineage of the files in here back to the original LAS file as well. So if we see an issue, we can actually find the file that we input to that. So while we haven't yet, the output of this tender process for the new LiDAR capture organisation will happen, I guess, during the next month or two. So we'll have to then get, work closely with them to build that pipeline. But it should be straightforward. We can mix. The other thing we can do is we can mix the LiDAR that's captured by the design crew into this format as well. So we did this with some of the stuff that GT did, the ground-based LiDAR. So you can have really, really dense LiDAR in with this LiDAR and all view it at the same time, which will be
Thank you.
Thank you as well.
Good work.
Thanks, guys.
Thanks, everyone.
Thank you. Thanks for your time. So I'll capture a lot of this information and store it in Confluence just from a project sense. We'll sprint on sprint, we'll do the recording, we'll have it in there, we'll capture some feedback and any questions that were raised so we can look at what do we need to do to reintroduce back into the sprint for the team to focus on if there's another priority in terms of stories or questions that you have. So I'll send the link after the showcase and along with the
Yeah, so we just want to get targets to the
organization. Yeah.
And all that. I know there was a question out last week.
Yeah.
So is that what was it that needs to do?
I was going to say, again, I can help you with that, whatever
The tender is. Luke will do. Yeah, we can. You definitely do that. Luke comes and sits with us a couple of days a week, so we're trying to get him a bit more involved in the detail.
All one of them are push the point.
Yeah.
Right. Which is a lot that we sell the points per square meter.
Yeah.
Great thing.
Yeah.
And there's others that are like they're hiding other issues.
Yeah.
20 points that Sharon got. Some speed line at 20 to get This were all that.
But the other, like, it depends on what equipment they're using. So some of the equipment, they're like, as you go slower, you can increase the samples per.
Yeah.
But some of them don't. Like some of them store the whole waveform and all that. So the question is, what equipment are they using?
We want to influence that. We obviously want to influence how they fly, where they fly, all that sort of stuff.
Right. I'll have a chat with Miss. Will probably reach out, and I'll reach out just from a workshop. Just reach out to some SMEs who will probably talk. I'll prepare some facts and information just around. So just to do with MCS and how and the modelling that we're doing, and just make sure that we're on the right track, and just get some feedback and how we do the right thing with the engineering. So,
These cases, these things descriptive, like how they're going to be, or we're just going to why what we
The visualizations piece is
yeah, I know.
it's not but
We're
we're
focused with the outputs, with all that.
process
That MCS one's the key one, especially get around. This is an interesting part of it where we process LiDAR data like October.
Oh, yeah.
If you're coding it at
2019,
2019, the issue or was it 2020, around what happens if you get later down there we're spoken about, well, if it's just inside the 2019 or if it's like a centimetre away from BP3, and I just haven't quite got my head around. Does it move throughout the year or how does it get prorated, that sort of thing?
But we can come up with a scheme for how you want it.
Yeah, that's right. So let's maybe talk in a couple of scenarios. So like, how do you like something metre and a half away in October? What does that get coded? What about a metre and a half away? January.
yeah. Okay.
Okay,
Cool. All right.
Thank you very much. Yeah.
I can get the right thing there.
Yeah.
Get some of the things that I've sort of been trying to.
Yeah, feed it through to them, and then they can come to us, and we can work it out. Yeah.
we'll set something up next week.
Cool.
Yeah, thanks.